let's expand on what we already know what a polynomial is all about. But now I want to start getting a little bit more particular about what we're doing. For example, let's talk about things like how many terms we have. What type of polynomial is it? Is it a linear? Is it a quadratic? Is it a constant? Is it a cubic polynomial? These all suddenly start describing the type of graph you're going to get. Interesting. Okay. Now, let's talk about what kind of coefficients do we have here. Do we have integer coefficients? We also refer to them as integral. Integral. I think you remember that from Math 20-1. Do we have rational ones? Where do we have something like fractions as our coefficients or decimals as our coefficients? Or are they some other kind of real number like a root 2 or something like a -5 or a root 7? Tell me more about it. And then, of course, one of the most important things here is what is the degree of the polynomial, which, of course, is the highest power of the variable. All right. Let's go. Here's a really nice table that should describe it all for us. First things first, here's a polynomial function. What the heck is this first one mean? Well, the C means that it's just a constant value. This would be like y equals to 5. Huh, well, that's weird. Okay, well, if you were to draw this out like this, there's our nice little axis. You would go 1, 2, 3, 4, 5, and you would just draw a nice little line because all the values of y are going to be 5. Huh, okay. Well, how many terms will this have? 1. What's the degree? Well, there's no x. Since there's no x, this is a degree of 0. Wait a second, what do you mean? This is x to the power of 0, which equals 1. So you can actually write this as y equals to 5x to the 0, knowing that that is just 1, meaning that y equals to 5. Oh, neat, sneaky, isn't it? Okay, so what type of polynomial is this? Well, since it's just equaling to a number, this is a constant. This is a constant. Constant. There we go. Okay, which is, if you think about it, right here, the type of polynomial is a constant. Oh, okay, so that means this never changes. No matter what value of x you put on here, y is always going to equal to 5. Ah, now I'm getting there. Ah, I got the trick in here. Okay. Now, look at ones that you're familiar with from Math 10C. Y equals mx plus b. Okay, so how many terms do you got here? You have 2 terms. Okay, what's the degree? Degree is 1. Boom. Okay, all right. What type of polynomial do you have here? This is a line, linear. Of course. Look at this one from Math 20-1. Okay, you can figure that one out. Number of terms, 1, 2, 3. Isn't that interesting? 3 terms. Okay, what's the degree? Well, the highest degree is 2. Of course, this being a quadratic. Okay, let's keep on going. Okay, look at this one. Ah, interesting. Number of terms, 1, 2, 3, 4. And that's kind of cool. Degree, highest power, that's 3. What type? This is a cubic function. Okay, and why do we have to learn all of these? Well, remember, constant is a straight line like that. Linear could be some kind of line going that way. Quadratic, of course, is U-shaped. And then the cubic, when you find out that this is a cubic function, that's going to have a specific shape. Look at the next one. Okay, look at the next one. This one here. Okay, wow, to the power of 4. Well, that's actually going to be called quartic, but I'm jumping ahead of myself here. This is a quartic function. That's what 4 means. So how many terms do we have? 1, 2, 3, 4, 5 terms. The degree, of course, is 4. The type of function is quartic. Okay, this one here, look at the last one that we have here. This, of course, oh my goodness, look at the terms. 1, 2, 3, 4, 5, 6 terms. The highest degree is 5. Okay, this is called a quintic function. Okay, Wow, some really, really cool names for these functions. And again, it's surprisingly enough, what's going to be most important to us is this degree, because the degree, like the ones we know, describe the kind of graph that we're going to get. Ah, I see, I see, I see. Okay, so let's take this to the next level. Bada boom. Look at this. Uh-oh. Tell me what kind of coefficient I have here. What are the coefficients like? Well, in this particular one, look, all of these are positive and negative numbers. So these are referred to as integral. Integral renamed integer. Okay, right? Okay, it's like if you think of a name like the name Bob, his formal name could actually be Robert, right? So Bob is short for Robert. So in other words, integer is short for integral. Interesting. Okay, look at this one. Aha, this one here has got that nice little fraction in it. Well, guess what? Type of coefficients, that's a rational. Okay? And then finally, look at this one over here. Right? This one's got, yes, it's got a square root in it. So being that this one's a square root, this, of course, is a real. Okay? This is a real coefficient. In other words, yeah, that square root happens to bounce in there for. Okay, so let's use all of these. I'm going to throw a whole bunch of polynomials at you. Now that you know everything about polynomials, you tell me a few things about them. Okay, number one, tell me whether or not it is an actual polynomial. Well, take a look at this one. X is on the bottom. Guess what? No way. No, that's not a polynomial. So guess what? We don't care about the rest of the stuff. We don't care. That's not a polynomial. Don't go there. Okay. Now, let's look at the next one. Is this one a polynomial? Well, yes, it is. Okay. It matches all the definitions of polynomials. Take a look at those powers. Every one of those powers happens to be a nice number, a nice whole number. Okay. So this, in fact, is yes. Okay. Let's find the degree. Who's the biggest degree on this one? Well, that's got to be 5. So that's got to be a degree of 5. Who is the leading coefficient? The leading coefficient goes with the highest degree. So that one is, in fact, -2. The constant term, yep, the one that doesn't have an x by it. That is, of course, our y-intercept. Boy, this is fun. This is fun. Let's do this one then. Okay, is this a polynomial? Well, yeah, it is. Okay, perfect. Yes, because all the exponents are nice positive whole numbers. Okay, perfect. Its degree, yeah, looks like 4. You betcha. Its leading coefficient, yeah, goes with the highest degree. That's -4. Doesn't have a constant. Oh, yeah, there it is. +3. That's your y-intercept. Oh, this is a piece of cake. Okay, let's go with this one then. Okay, is this one a polynomial? No way. No, 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 no. It's not, because that's the square root of an x. So we don't care about these other things. Okay, moving on. Let's go back. Here we go. Look at this one. Is this a polynomial? Hold it. Hold it. This is a degree to a decimal. No, this isn't a polynomial either. The reason why it's not a polynomial is because, remember, those have to be whole numbers. They have to be like 0, 1, 2, 3, 4, 5. They can't be negative. They can't be a decimal. They can't be a fraction. Forget that. No way. Okay, brings us to this. Well, that looks an awful lot like the stuff you did in Math 20. So is this a polynomial? Oh, gosh, yes, it is. Absolutely it is. Okay, well, I can't remember what the next thing is. Oh, tell me the degree. Oh, well, the degree is found then by multiplying all of these x's together. Remember FOIL, right? First, outer, inner, last. Yeah, just forget about these numbers here. The degree is determined by multiplying all of the x's together. So if you think about this, the first term works out to be 10x squared. Okay, so the degree of this guy is in fact 2, and its leading coefficient happens to be 10. But now, here comes the fun part. Watch this. What is the constant term? Well, remember, the constant term was determined by the y-intercept. Remember? Okay, when is a y-intercept a y-intercept? It's a y-intercept when x equals to 0. So watch this. Do you remember how we got rid of the other numbers and figured out these guys? Watch this. I'm going to get rid of all of the x's. Why? Because this guy becomes a 0, means 0 times 5 is now 0. This guy becomes a 0, which means 2 times 0, it becomes a 0. And look what you have. You have minus 1 times 7. Your constant term is minus 7. Oh my goodness. That's how it works? Yes. Okay, so look at the next one. Oh, this ought to be very, very funky. Let's look at that one. Okay, is this a polynomial? Yeah, all the powers are positive whole numbers. So yes, it is. But now, let's go back and see what the top of this chart says. We have to find out the degree. Okay, let's figure out the degree. Just like I did before, to figure out the degree, just get rid of the constant numbers. Just get rid of these guys. Okay, I'm just going to get rid of them temporarily. So, oops, I got rid of the wrong one. Oh my goodness. There's the constant. So there's my minus x. So look at this. We have x times 2x. No, we don't. You forgot it's squared. So this is x times 2x squared times a minus x. Interesting. So we've got x and x makes x cubed. That makes x to the 4. Neato. Okay, so that's x to the 4. This is a degree of 4. Now, what's the leading coefficient? Okay, well, this is a 1. This is a minus 1. And don't forget to square this. So that's 1 times 4 times a minus 1. Your leading coefficient here is minus 4. Ho, ho, ho. Neato, neato, neato. Now, let's figure out the constant term. A constant term is, remember, it is an x, or I should say a y-intercept. So all of your x values are now gone. That's gone, and that's gone. But don't forget, this guy's still squared. So you have a minus 1 here, you have a 3 squared, which is 9, and you have a 4. Well, 9 times 4 is 36 times a minus 1. This is minus 36. Oh, neat stuff or what? Yeah, there's a lot to learn in this one, isn't there? Okay, so go back and watch this podcast again, especially this last little bit here becomes incredibly important when you're trying to figure out what the degree is, what the leading coefficient is, and of course, what the y-intercept is.